What's up, guys? So I ended up waking up and I felt like coding some more. And I didn't really feel like coding in Python. Um, I'm like going through a thing where I want to try and get experience in a lot of languages so I can, mark a bunch of check boxes off on resumes so I can say I know a lot of things so I can like spread out a wider net. It's probably not the right path. I think I should probably just stick to Java. There's a lot of jobs in it. Is it everybody hates on it, but I don't get why everybody hates on it when like C sharp's like the same thing, but like people don't hate on that. I can also use Kotlin with JVM, so I don't know. There's pretty worse ecosystems to work in. I think there's probably like a lot of alternatives to a lot of like machine learning stuff with Java compared to Python. And like everybody hates on it, but I don't know. When I made my Spring Boot app, I enjoyed it. So when I've made like other things in Java, I've enjoyed it. I guess it definitely is a little bit more verbose than Python, but I feel like I gain a better understanding of how it's actually getting broken down underneath the hood. Anyways, I'll stop talking about that and I'll get to the algorithm. Best time to buy and sell stock. So we are given an array of prices where prices I is the price of a given stock during the ith day. You want to maximize profit by choosing a single day to buy one stock and choosing a different day in the future to sell that stock. Return the maximum profit, and you can achieve this transaction. If you cannot achieve any profit, return 0. I assigned it as peak minus pit, but that's also 0. Anyways, I don't want to look at my code on here, but I will show my first result first, because I solved the problem, but I still had a failed case, and I knew it was not going to be a good answer. But I was just trying to answer it quick, because I'm trying to go, like, I don't know, watch a movie with my partner. Anyways, so this was my original outcome. This was my original solution. My just straightforward, get it done. It involved a double for loop, which I instantly knew was gonna be bad news. But I figured, what the heck? I tried it. Then LeetCode gave me a huge data set that just took too long to run, and it crashed. So, I mean, I knew that was going to happen because I knew the double for loop was so ugly, and I knew deep down that there was a better way to do it. So when I seen that error code, I wasn't like super disheartened, but I'm like, all right, I need to take a step back and re-examine my approach. And I know like a common concept that I see sometimes in algorithms is like finding the peak and finding like the pit. Well, I called it pit because I don't know what the opposite of a peak is, but I know that that is like a strategy that you use sometimes is finding the peak. And I don't know if this is actually what it's called, if this is actually it, but I want to say this is dynamic programming. I honestly don't know the terms. Give me a break here, guys. I'm self-taught. No, it's dynamic programming. I'm like 100% sure. Um, so I'm like, yeah, I need to implement a new strategy. So let's get the IntelliJ up in here. So I'm like, all right, you know what? Before I even did anything, I was thinking, man, I was having problems visualizing it. My brain was it had the gears tinkering. So I literally drew a graph for this. Oh, there we go. This code would be so much more easier to explain if I had the graph with me, but if I could like make references to it. this isn't really to teach you guys how to do algorithms. This is just me cataloging my journey, all right? But I will explain the code and how it works because I'm not a bum. All right, give me a break. So, let me pull up my IntelliJ. So we're going to start out, we're going to initialize peak. We don't need the peak index. I can get rid of that. I think I initialized that when I was still kind of having like gears tinkering in my brain about what I needed. And, well, whatever. So, the we have a peak and a pit. So that's like the lowest number that we have encountered so far on our iteration, on our only one iteration. And then we need a peak and a pit. So the highest and the lowest. And then we also need max profit. So then we have a for loop, and we don't need to bother starting on 0 because these guys already got it covered, okay? So then we do it for the length of prices, and every time we finish, we iterate by 1. If prices I is greater than peak, so if the point we are at is greater than the current peak, then we need to assign a new peak. However, there's another condition that needs to happen. I think this would look better if I had them the other way around, so I'm not going to explain this part first. It makes more sense in my head. And then so I'm going to explain this bit here first. So if we make a new pit, we need to establish a new peak as well. Because it doesn't matter what the old peak was, because we can't go back in time and sell. We can't buy at 0, or we can't buy at $1 when something crashes and then go back 2 days later and like time travel and sell all my shares. It doesn't work that way. So if we get a new pit, we have to make a new peak. But then if we make a new peak, we need another condition. Because just because there was a new pit doesn't mean that the difference between the new pit and the new peak is going to be larger than a profit from the past. I'm not sure if that makes sense. It's a lot easier if I could actually like show it to you on the graph. But I thought about that. That was a base case in my head, and then I implemented that sort of logic or I guess it wouldn't be a base case, but it was one of the cases that I thought in my head. So then, it's a condition. We got to put in a conditional statement. Max profit equals, so if the peak minus pit, so the new peak minus the new pit is greater than our current max profit, then we assign a new max profit. And then once it gets to the very end of that loop, we'll have our max profit and we can return it. Simple as. So there you go, guys.